So we're going to be looking at position of a particle again, but this time we're given the velocity function, not the position function. So we end up with two different things that we're talking about. Displacement, which is just literally net change. Where did we start and where did we stop? And then we're going to look at the total distance traveled as before. So if we want net displacement, that means we go from when we started, which is 2 seconds, to when we ended, which is 4 seconds. And then we take our velocity function to convert it back to our position function. So this gives us 1/3 t cubed minus t squared minus 3t from 2 to 4. And so if we were to plug in 4, it will tell us our position at 4 seconds. Plugging in 2 will tell us our position at 2 seconds. Obviously the constants are canceling there. So we end up with this, 1/3 and then we're going to subtract the 2 second mark. So we end up with -20 minus -22, which equals 2/3. And then checking in our calculator, you can see it is 2/3. So net change just literally says, well, if we plug in 4 seconds, it tells us what our position is. Remember, this is antiderivative. So we take the antiderivative of v, we get our position function plus a constant, which is then subtracted. So plugging in 4 tells us our position, minus our position at 2 tells us the net change or actual change in location. So they're saying from 2 seconds to 4 seconds, it went 2/3 of a meter in the positive direction, right? So now what we want to do, though, is find out what the total travel distance is. Remember, this particle could go left and then right and then back left and then back right and then back left and then finally ending at that point. So it can do this, boom, 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 but it's just total distance is only 2/3. So we don't really know what the actual total distance is. We've just found the net displacement. So what we have to do now is break it up into its parts. So when did our function stop? So when did our particle stop? That's when our t values give us 0 for the velocity. So t minus 3, t plus 1. So at t equals 3 and t equals -1, our particle stopped. So which one is within that interval? It's 3. So that means we have to do now is set up two integrals and then take the absolute values of them. And so this should really be an absolute value here and an absolute value on the outside. So what we're trying to do is find the total distance traveled from the first point to the second point, from 2 to 3, and then from 3 to 4, and then change them into positive distances so that we can add them together to get total distance. So, like this. So we're going to do the integral from 2 to 3 of our function. And then we're going to add it to the integral from 3 to 4. And then we're going to take the absolute value, and then we're going to look at it and see why we have to split this. So our first integral, so from 2 to 3, that means it's traveled -5/3, which means our particle went left 5/3. -5/3 is its first distance. So far, our particle went from t equals 2 to t equals 3. It went this direction 5/3, right? Negative direction. So we want that to be a total distance, so that's why we take the absolute value of it, and now it's 5/3. Now we look at the next one. So with that integral, we get 7/3, which means our particle from t equals 3 to t equals 4, right, from here to here, it went 7/3 in that direction, to the right, because it's positive. So putting this together, we did 7/3 and 5/3 for a total of 12/3, which is 4. So the total distance traveled was 4 meters, and up here it's 2/3 meters was its net displacement. So you can kind of look at this picture-wise now. So from t equals 2 to t equals 3, it went left 5/3, and then from t equals 3 to t equals 4, it went right 7/3. So that would be a total distance of 4 meters. Now, if you notice the distance between them, from here to here, that means it had a net displacement of 2/3. So you can see 7/3 take away 5/3 is 2/3. So its net displacement was only 2/3. So if this person saw it and took a picture, okay, well, it's here. And then 2 seconds later, it's here. So it only moved 2/3. But what it really did was went left 5/3 and then right 7/3 for a total movement of 4 meters. So total distance was 4 meters. Net change was 2/3. So let's look at this. I've already got a picture for us. So I've moved it, modified it a little bit. There's our antiderivative, and then I moved it over our 22/3, which is what it was at 2 seconds, so that we get it at 0 to get a nice little picture. So watch it. If I hit play, it moves to the left. So it's moving over 5/3, and then back over here 7/3 for a total net displacement of 2/3. But you can see the total distance it went was 4 meters. So it's going back 5/3. And then this way 7/3 for a total of 4 meters. There you have it.